Actually, no. It's sine is opposite over the hypotenuse. So this will be for all the sine in the future. You'll use the opposite over the hypotenuse. Where did I? Here it is. So then you have this. So sine is represented like this. Your theta there, and then you'll use your trigonomic ratio. There, that's it. That's the name of the thing, which is opposite over hypotenuse. So when it comes to sine, you will either have an x, the length that you're trying to find out on the hypotenuse or the adjacent, if you're using sine. And I'll show you that when we go over examples. But you have the opposite over the hypotenuse here. So how you work out these ratios is, I like to cross multiply. So you have your theta there in most find the lengths of this leg or hypotenuse situations. And I cross multiply. So if you are trying to find out your hypotenuse, you put an x there, and then you'd have you'd multiply sine by x, and then the opposite by 1, which would still be the opposite, and then you'd have x sine with your theta, which is always going to be your known angle, or else you can't do it. You can't do the equation. And then if it's like this, you're going to want to get sine out of there because you're solving for x. So you're going to want to divide by sine of the theta, and then you're going to have this. And that's a number, and then that's a real number. And so that's one big real number, which gives you x. So that's how you'd solve for most sine equations. That's really also how you'd solve for most cosine and tangent situations. The only other thing that you do is you already know your hypotenuse, but you're trying to find your adjacents. So then this would be x. So then it'd be x1, which leaves you with just x, and then you multiply your hypotenuse by sine. Then again, this is all a real number, so then you know your length. Now with cosine, let's go back up there, everything stays like this, except for these two might switch, whether the theta is there or there. Remember, the opposite is always across from the theta. But for cosine, it's a different trigonomic ratio than sine. It is adjacent over hypotenuse. So that's if you're trying to find out the adjacent or the hypotenuse. But if you're trying to find out the hypotenuse, and you're trying to decide between sine and cosine, they have different numerators. So if you know, you either have to know the opposite or the adjacent if you have to find for the hypotenuse. And whichever one you'd have, you use the one in the trigonomic ratio. So then again with this, you just use the same method of solving like I showed you there, and you should turn out fine. Now tangent is not with the hypotenuse necessarily. It has its trigonomic ratio. Then you see there's an opposite and an adjacent. It is opposite over adjacent, which doesn't have the hypotenuse. I find that most situations you have to use tan over these two. So you'd use that if you need to find your opposite or your adjacent, and you have an opposite or adjacent. And you still use the same method of solving like you did in sine. And again, you have this, your thing. So all these are going to be the exact same as it is, unless if your theta is over here, because it's different. Now your adjacent is going to be over here because it's touching your theta, and then your opposite is going to be away from theta. And your hypotenuse is always going to be the longest one that you have, the longest side that you have. So now, let us try and solve.